It is the same graph. The difference here, though, is that this time we're going to rotate this figure around y equals 8. So first things first, if I'm going to rotate around y equals 8, what kind of a slice am I going to take on this one? Dx slice or a dy slice? Dx slice. All right, so a dx slice. So let's do that here and here. So now I'm going to put on this curve here. This curve is y equals 2x squared, just like it was in the last one. I'm just going to put on this curve general coordinates of x and y, because it's going to help me keep track of top and bottom and what I want to subtract, etc. Now, if I put on this curve, this general coordinate, what would be the coordinates down here on the x-axis? I hope that wasn't mine. Okay, that's good. All right. X and 0. Good. Up here, if I draw a line straight up, now what are the coordinates going to be? Way up here on the line, y equals 8. X and 8. So it's important to kind of keep those things straight. Is this going to be a disc or a washer? Washer. It's a washer because this figure isn't flush with its axis of rotation. Now there's two ways you could get a disc method rotating this figure. One would be around the x-axis and the other one would be around the line x equal 2, which would mean you'd be rotating it around this way. So let's draw ourselves a little washer and see what we can come up with. So not exactly a thing of beauty here, but it'll work. We've got an outer radius, R2, and an inner radius, R1. Let's see if we can't find the volume of that one washer. Volume of one washer is going to be pi times R2 squared minus R1 squared times the thickness. What's the thickness for us in this one? Dx. Good. So I need to figure out R2 and R1. R2 is the outer radius. So that's going to be the distance between this axis of rotation and this point. So let me kind of sketch that in for us this way. So that's R2. This one right here is R1. Now I put these points on our graph here, the xy, the x8, and the x0, to help us find these radii. As far as the radius is concerned, R2 is going to be what minus what? 8 minus 0. Good, so top minus bottom. 8 minus 0 is just 8.
Does it matter where your axis of rotation is compared for the top and bottom?
Yes. Yeah. Top. Well, no, the top here would be 8. That's so that your distance from the axis rotation down to here is just 8. You know, I guess if you subtracted it in the other direction, if you did 0 minus 8, once you squared it, it's going to be 64 either way. So, yeah, it doesn't matter too much in that respect. Yes?
So I'm just confused with this top minus bottom thing because to me me, it looks like that parabola is like on top, and that straight line at zero's on the bottom.
Well, remember what's going to happen is you're going to rotate this around this axis. And what we need to do is find the distance from the center, which is right here, to the point on the rim.
So in this case, it's not really top minus bottom. It's farthest
Well,
from the.
Well, it's just you can still it's still a radial distance.
Okay.
You know, it's this distance here. Now, if you wanted to subtract it the other way, I mean, I guess once you square it, it's still going to be positive. But I still think of it as top minus bottom. And in general, I'd probably suggest you stick with top minus bottom and right minus left. I mean, maybe you'll be okay in other situations,
Right.
but I won't guarantee it.
I mean, just visually, this is confusing. You know, if it's top, because this is bottom minus top. If I'm looking at the shaded area.
I think I see what you're saying, but you know, I'm just trying to find this distance. Yeah, I kind of see what you're saying. It's like, well, wait, this is really the outside of the tire, and once it gets up here, that's the top. But we're just trying to find the radial distance, and looking at the graph, this point is on top, and that one's on bottom. So that's the way I'm going to subtract them. R1, now here's where it's nice to have these points labeled. So I got them here and here. Top minus bottom relative to my graph would be 8 minus y. There is one problem with this, though. Oops, not dy. What's the one problem that I have with my expression for the radius? Good. It needs to be in terms of x. I know that because the slice that I took to get things started had a dx thickness. If this is dx, then everything else needs to be in terms of x. So I think we solved for y in the previous problem. No, actually we have an expression for y, right? It's y is 2x squared. It's great. Now I've got all that I need to plug in and find the volume of one washer. Pi times 8 squared minus 2x squared squared again times dx. It's the volume of the outer minus the volume of the inner. So basically, if you looked at this as being a very thin torus, or the difference between two cylinders, you're just finding the volume of the outer one minus the volume of the inner one. So you're just subtracting off that whole to get what's left on the outside. Pi times 64 minus 4x to the 4th dx. Oh, you know, I did forget the 8 minus that. Oh, man, thank you. That's going to make this a little bit more tedious, which is regrettable, but it is what it is. So it's going to be 8 minus 2x squared, then the dx. So then we get to square that all out. So that's going to be annoying. 64 minus 64, that'd be minus 32x. That's squared in there. 32x squared plus 4x to the 4th dx. At least we get a little bit of a break in one way. Do you see it? 64's cancel each other out. I'll rewrite that as pi times 4x to the 4th minus 32x squared dx. Oh, is it going to be a plus, sir? Let's see, if I distribute that, yeah, this would be a minus and that'd be a plus. Thank you. Last but not least, we need to set up the limits of integration. I'll take the pi out in front, negative 4x to the 4th plus 32x squared. A Let's look back at our figure for the limits of integration. I'm integrating with respect to x. So my limits of integration here are going to be from where to where? 0 to 2. This slice can be taken and still be in this region as far to the left as 0 and as far to the right as 2. So 0 to 2. Happy ending? Yes. All right. 16 pi over 3. Wait, no, not. Let me double check that one. This one was C, right? We did C? Yeah, 896. Yeah. 896 pi over 15. It's not a stupid question unless you don't ask it. Please.
When you switched the x and the y, you got 8 minus 2
Let me try and catch up to you.
r1 equals 8 minus y,
Yes.
and then you somehow came up with 8
Oh,
minus 2.
yeah. Good question. So our original function here is y equals 2x squared. So these two are interchangeable. So right here, I knew that I needed to write things in terms of x. So replace y by 2x squared, because that's this function right here, y equals 2x squared. So that's where that came from. All right, appreciate it. Yeah, Noor. Oh, they tell you. In the problem, they'll tell you that it's going to rotate around, for instance, the line y equals 8. So, yeah. And here's a quick glance at the problem. Part C. So here's your function, and it's bounded by y equals 0 and x equal 2. So that's the x-axis, and that's the line x equal 2. And in part C, we're rotating around the line y equals 8. So it'll tell you. Yeah. Okay, I had wanted to do one more, but I think I'm going to have to cut it off here. Let me give you some homework. 1 through 21, 31, 33, and 35. So that's section 7.2.